went to, again, vertical board arrangement, but just the control panel and back. Actually, that first one, much narrower than what we ended up with. But the front panel, pretty much everything was mounted to it. So the goal here was to basically minimize point-to-point wiring for two reasons. One, reliability of the product, making it easy to build, but even more so to protect ourselves from a customer support standpoint. One of the things building this business, we said, an opportunity for us is in the kit area because nobody was doing that. We could go underneath the radar of the Japanese and American companies. I think the name was Tensec at the time in the U.S. They wouldn't really pay attention to us if we did a kit. They think, oh, it's a toy, or these guys aren't serious, they're not going to sell very many of them. Our plan was always to make both kits and build radios, but we figured we'd sort of go under the radar and sneak up on it. But we wanted to be able to support the company and be successful, and we knew that customer support would be our Achilles heel, and we didn't do it well. And we put a lot of effort into doing a good job of that. But part of that's on the design. We actually make these designs easy to troubleshoot, hopefully easy to build so you don't make mistakes. One little trick we did, and those of you who built some of our products have run into this, is the first K2s that we did, we put all the resistors in a cup, put them in a bag, and made a bag of parts. So you had a bag of resistors that you had stuff on the board to solder them in place. We discovered a lot of people would swap 1K and 100 ohm resistors throughout the night. Oh, that TR switch isn't working. About the third or fourth one of those, we know what they were doing. So sort of out of self-preservation, but also to keep my sanity, because I was doing the kitting at the time, we actually got the resistors sequenced by a company in the sequence of assembly. So then I'm just putting in a single package in the radio so I don't screw up and forget something. But more importantly, you guys are pulling the parts off and you're pulling them off in sequence. And so, yes, you look at the resistor code, you're much less likely to get it wrong. So that was sort of this, you know, in addition to doing no wiring harnesses, mounting all the controls in the front panel in this manner, we wanted to really design the kits and the manuals and everything so you had a high likelihood of succeeding and a low likelihood of calling us on the telephone or by email. Not that we wouldn't be there for you, because certainly we've talked to a lot of people over the years, but the goal was not to be overwhelmed by that, because I can kill you right away at any company if you can't, you know, handle your customer support. So we wanted to make sure that the design was solid from the start. First prototype demo, and actually we made the first QSO at about 4 o'clock in the morning before this demo. This was a NorCal QRP meeting. Anybody here ever been to one of those meetings up in California? They hold it at the California Burger. You can see that in the back. This is a illustrious place. It's actually pretty cool. We take over the whole restaurant, basically. And we have guys on the floor with their projects spread out. Well, you know, there's like 5 or 6, there's really designs. People will bring stuff in. It's sort of like the original California Computer Club that Jobs and Wozniak would go to, you know, for their computers back in the early days. This was sort of similar for guys that were designing and modifying radios. It happened to be QRP radios because those were facilitated and accessible for most people. We were doing something well beyond most of what most people were doing there, certainly the complexity of a radio. This was microprocessor control, you know, have LCD on the front, and we hadn't told anybody at this point was how high performance it was. Actually, we didn't know it at this point. We had designed this as a kit, and we said, okay, kit, middle of the road, sort of TS50, Icon 706, nice but not stellar performance, because it's a kit, you're going to build it and have fun, and it's going to work well. I got in the lab, I'm a performance nerd, so I have all the fancy test equipment and everything else in the lab to play with and test the radio. So I started looking at phase noise, dynamic range, sensitivity, and I started looking at the design, and I said, gee, this is better than we thought it was going to be. And I started looking at how much overhead we had in the circuitry, and one of the key things you do in any radio design, say on receive design, is you balance your noise figure versus gain versus dynamic range throughout the receiver. You put a bunch of gain up front to get great sensitivity, and you can have way too much and have it overload really easily. Vice versa, you can deficit or have a great intercept point. There's a lot of radios out there like that, actually. By the way, a pet peeve of mine is ads that include the intercept point in the end on a receiver, because it's meaningless unless you're comparing apples to apples in terms of what the sensitivity of the radios are when you look at the intercept point. You have the exact same sensitivity in the radios, and the intercept points are comparable. But if you have a radio that has a minimum discernible signal of -121, it has a high intercept point, being compared with a radio that has a typical MPS with preamp off of like ours of -131, which is quite useful. It has a lower intercept point as a result. They're not comparable. In other words, just because a guy has a higher number doesn't mean he actually overloads later than we do. You actually have to look at the total dynamic range. And so rather than using intercept point numbers, which are easily malleable by the marketing department to make your radio look good, we published just the raw dynamic range numbers, the blocking and IMD dynamic range. Anyway, getting back to this, I started taking the measurements and testing, said, gee, I can squeeze a little more out of this wing. Give me another week or two, and I think I can get this done. It took about 2 months of late nights doing that, but we actually squeezed both the phase noise way down and the performance way up on the dynamic range, where we actually had a radio that we thought, we still didn't quite believe it, we thought was going to be one of the top performing radios in the market. We didn't really know how well we were going to do with this, but we ended up being the top performing receiver in the market when we came out with this kit, which was sort of shocking to ARRL. I took it back there. They tested it in their lab, they sort of looked at me and they tested it again. And they said, wow, this is sort of real. I said, yeah, this is neat. So I came back to Wayne and said, hey, Wayne, it really does match our numbers back. That works. But what was cool about this is now we had a sort of double whammy in terms of marketing, because we had both a kit that was cool and fun to build and workable for people, accessible. And we're going to give you bragging rights once you built it. So this is wonderful. You know, but obviously when you build something, you get 10 dB of advantage anyway. It's got to work better because you built it right. I've had a few of those. People in the back here. Those are Chuck Adams in the red. This is Andreas here. I forget Andreas' current call. I don't know who the guy is with the hat and smiley face over here. But N6W Mike Guy, if you guys know Mike, the glasses there. Dave, what's Dave? British fellow with the glasses in the very far right here. I think it is. 1999, January 22nd, after a lot of work, we actually took orders back, I think, in February of '98 for the first 100 field testers. Do we have any field testers in the room here that were K2 field testers at all? Didn't get anybody this time. We actually, these guys were wonderful because they gave us great feedback. They gave us money, which really kept us operating. And we gave them a radio. And it was we had a little field test email reflector, which was a precursor to the Elecraft reflector, which now has like 5,000 people on it, where we actually corresponded back and forth and debugged these radios and made sure that we made the manual use of everything else, because it was quite a challenge getting all that together with two guys operating out of their basements in California and basically funding this thing out of our pocket. One other little known fact is right about that date, January 22nd, 1999, is when Wayne went full-time on the project. He was still working interval up until that point. I went full-time in July of '98, so it's a little bit 6 months or so before that, and was trying to pull him out of a nice cushy job at interval to do this full-time. I had made the jump once before, so I sort of knew what it felt to run off a cliff and hold your breath and hope you're going to hit the ground with your feet. Wayne, it was in this nice situation, you know, I'm going to leave this and so on. And when he finally said, hey, this is real, there's 100 guys that we're shipping to here, he actually made the decision to jump also. And it's very fortuitous, actually, because this company that Paul Allen had set up a bunch of money in the bank as a think tank to design products. Paul got tired of it about 6 months after that and rolled it back up. So Wayne looks backwards now and says, hey, that was a really good time.